Hi, and welcome back to the NewSpaceVision podcast sponsored by LiveEO, where we discuss new space technology, finance, and innovation with executive founders and more exciting people from the space ecosystem. I'm Sam Shivara.
And I'm Daniel Seidel, and together we are the founders of the Earth observation company LiveEO and NewSpaceVision. Today we have two first-timers. I'm really happy to say that. So we are joined by Shoaib Iqbal. He is the co-founder and CEO of the hyperspectral satellite company Esper Satellite Imaging, or we just call it short Esper. And yeah, you are the first one in the podcast who made it twice to the Forbes 30 under 30 list. Sven is there once. So that's the first one. And you are the first Australian company from the other side of the planet. You made it very, very late to our podcast. So thanks for that. And yeah, we are super happy to have you. And yeah, you have a very impressive story. So you founded Esper while you were finishing the bachelor degree, just being 21 years old. And we all also have seen that you started companies before that. So we will dive into this. But yeah, we're happy to have you here, and you can walk us through how did you and why did you start a company with just being 21 years old?
Yeah, thanks a lot, guys. I've been a pretty big fan of the podcast, so it's really great to be here and to be actually talking with the two of you as well. Yeah, my story has been pretty interesting going into space and going into, I guess, Esper specifically. I think it all the way basically dates back to me even in high school. That's where I really started getting into startups, even though I didn't really start any company per se, because obviously I was like 15, 16 years old, but that's when I really got into technology and just like wanted to build really cool products. So started basically like everybody else does nowadays, where it's like, if you go out and ask people in their preteens or in their mid-teens, everyone wants to be a YouTuber nowadays. We were probably, or my generation, at least one of the first ones to do that. We started off as like a technology YouTube channel, and then we grew to maybe like over a couple of thousand subscribers. And we're like, wow, we're actually gaining traction. Why don't we start building some of our own technology? That really helped us get into a lot of like local and national science fairs. And that was, I guess, my first exposure to, I guess, what you would call deep tech, where you just apply really hard scientific concepts and try to build like a physical product or sometimes a software product, depending on the application and the problems that you're really trying to solve. So when I think it was like 2015-ish, when we ended up winning. So it's taking a bit of a step back there. Originally, I'm from India, but I grew up in the Middle East. So it's a very different upbringing where you're not really a part of the Middle Eastern culture, but you're not exactly considered, proper Indian either. So it's like this, growing up across two sides of the culture. It just sort of, the schooling system is very different there. So we basically end up going into this schooling system where they structured an entire national science fair, where we ended up taking one of our first products that we were building under the same banner where we had our YouTube channel, which was basically an eye tracking software, where we took apart a PlayStation 3 camera, if you ever had the motion sensors and stuff. And we basically put IR sensors on it. I had to literally do surgery on one of the lenses to get one of the filters out. Otherwise, you couldn't really see IR light coming in through the PlayStation 3 camera. And then we basically literally mounted onto one of my dad's old glass frames. And that was like our first hardware project that we really built. Since then, it's just been sort of, really been intrigued with a lot of just hard technology problems. And of course, from a technical side, now I've, shifted a lot more over to the business side. And that's how, once I got into university, I really wanted to start something. I really wanted to take whatever, skill sets that I was learning and basically be applying them in real time. So we kind of tried the eye writer, that's what we called it, the eye tracking software idea again. And that was a really good exposure for us to just computer vision and just optics in general. And in 2019, me and my co-founder, Joey, we ended up going to a hackathon called the UniHack. So that was basically Melbourne's largest hackathon, and we ended up going into the space idea. Initially, we were building completely different than what Esper is today. We were basically doing Gen AI for satellite payloads before Gen AI was even a thing. With that idea, we ended up winning, and we were like, hey, this might actually have some legs. Let's try to spin it off and see what happens. Tried selling the idea to a couple of customers for the next 6 months to 12 months, realized no one really wanted to buy it. But that was also around the time where we were having the Black Summer fires here in Australia. So that made us realize, hey, we're already working in space technology. We have a little bit of background and some understanding of how optics work, why don't we, put those two things together and try to see if using Earth observation, whether we can solve this challenge that we're actively facing from a forest fire and disaster management point of view, and, try to launch, build payloads and try to launch some of these up into space. And that's how we stumbled across hyperspectral, and that's how we ended up that's how Esper basically started. So yeah, we were still in college. So I started the company when technically the idea came when I was 19 years old. We didn't incorporate it until like a year and a half after that. But yeah, we started off pretty young to just like hackathon ideas and just side projects that we really wanted to work, just because we really wanted to work on a lot of cool stuff besides from just our studies.
Yeah, super cool. And you can really see like this thread from optics and AI down to what you're doing right now with Esper. But could you maybe tell us a little bit about what the current company is about and what you currently do? You start with an idea about like how can we solve potentially problems like wildfire and so on. But what Esper does today is broader than that, right?
Yeah, that's absolutely right. So what our company does at the moment is that we are building and launching Earth imaging satellites, specifically hyperspectral satellites. The work that we do is that we're building the payloads from the ground up ourselves in-house. So everything from the optomechanical design to the rest of the payload. And then we work with providers to get our payloads onto existing satellite buses, posted payload platforms, whatever the logistics might be for us to actually get up into orbit. And then we deliver the data to our customers. So far, like a lot of our focuses have been on the resources sector. So we've been doing quite a lot of work with mining, within mineral exploration, all the way to, on the oil and gas sector, where we're doing a lot of asset management that, from a climate angle very much overlaps with everything from, looking at environmental risks of new mines all the way to, emissions tracking and whatnot. So that's been a lot of our focus. And that's where, a lot of the story, us being inspired by that forest fire, I guess it's a kind of weird to say that we got inspired by, a natural disaster, but that is something that really prompted us into action in terms of actually doing something for the wider problem of climate change. And while we're not actively detecting fires, we are looking to be tangentially impacting this problem by making basically other industries that are really important to Australia specifically, helping them be a lot more efficient.
Yeah, and I think Sven and I can feel that, right? You mentioned the wildfires. I remember Sven and I being in California 2019 in the German accelerator, and we could see the mountains burning, basically, right? And I think it's a common thing in our industry that we can't eliminate wildfires, but we have a core technology which can solve this, right? What I'm curious about is because you have a hyperspectral sensor, right? Can you tell us a bit how this helps in these use cases?
Absolutely. So the way you think of a hyperspectral sensor, at least at our company, is we essentially look at it as a chemical sensor, because the way a hyperspectral sensor works, for the people in the audience who don't know what it is, we basically take hundreds of different images of different colors simultaneously. So instead of just taking red, green, and blue like a regular camera would, we take hundreds of different colors within visual, near infrared, going deeper into shortwave infrared. So because every element reflects and absorbs light very differently, this gives us spectral signatures that we can monitor and classify different minerals, different objects on the surface, all the way to different gases in the atmosphere from basically single images. So utilizing this imagery data, we're basically looking at, of course, on the resources sector, we're looking at new mines, being able to extract them sustainably by looking at existing vegetation, the existing environment around it, but then also monitoring emissions coming out of, let's say, pipeline leakages, or, super emitters where you have specific, activities for an oil and gas. Let's say you may have a processing facility that's actively emitting a certain type of gas, and being able to monitor that on a very large basis. That is basically, again, us being technically a chemical sensor, looking at surface level to atmospheric level chemical concentrations, we're able to decipher quite a lot of these industrial activities and the environmental impacts from these industrial activities.
Yeah. And you've already mentioned so many different use cases, right? And what we've always been seeing in our own company, LiveView, that oftentimes the details are in the nitty-gritty details, right? Like, how are we solving that problem specifically, and how does a sensor need to look like to really solve that problem? So could you maybe tell us a little bit about how you have explored these use cases and how you have gathered feedback from customers, which you are now integrating in your product development?
Yeah, so honestly, all of our sensor development so far has been customer defined. We didn't take the approach of like, what's the best sensor that can we build? We didn't take the technology approach of, let's push on GSC, let's push on spectral width or this type of spectrums that we can capture. For us, it really came back down to, all right, what is the type of market that we're going after? Who's our most ideal customer who is going to be most open to buying the imagery data from our V1, V2 sensors? And then eventually we came down to what are the specific things that we need to build within our sensors to actually meet that. That's what we proved out in one of our first demonstration satellites that we launched early in the year. The intention behind that spacecraft was to, obviously as a company, demonstrate that, hey, we can build a sensor from the ground up and then deploy it into orbit and actually operate it. The specs that we went for were primarily focused around a lot of vegetation and agricultural customers. And those were one of the first people that we as a company started engaging with here in Australia, because agriculture is basically our second biggest export as a country. So that was a really big pull there. However, while we were doing this process, we had a lot of interest from mineral exploration and mining companies come to our table as well. And that's when we started exploring in terms of, okay, what are the specifications that these folks need? We realized very quickly that the sensor or the demo sensors that we developed cannot meet the needs, and using the type of minerals that they're looking for, whether it be lithium, cobalt, and just the demand curve that we're seeing from a macro perspective for critical minerals, that's so far been really educating our sensor development. So in 2026, we're launching a batch of 4 satellites. We call that entire mission 4-leaf clover. So that's where we're really focusing on shortwave infrared and having mid-resolution. So we're not the highest GSD. We're not going sub 10 meters at the moment. We're still like about 13 to 30 meter across that entire spectrum, but we are very low cost and very effective from a spectral perspective for these mineral exploration customers and for a lot of these oil and gas customers. It's a bit of a long-winded answer, but that's how we've been approaching a lot of our product development and how we've been engaging with our customers based on the demand that's actually been where the market's been pulling us. And critical minerals and energy, just like the energy sector in general, has been something that we've been wanting to impact in a positive direction, because what we believe is that if we can, even let's say, the lithium that goes into our cell phones, our car, whatnot, if we can make that, if we can make the extraction of that mineral a lot more sustainable, reduce the cost and reduce the emissions in that entire process, we feel like we can make a huge impact tangentially to all of their assets, all of their areas of climate change.
Yeah, that totally makes sense. And I think I wrote this investor's guide to Earth observation, and there was the optical wave and the commercialization, right, with all the players, Planet, Satellogic, Black Sky, etc. Then there was the radar wave, right, literally with the ICEYE, Capella, and others. And now I see these two, like the thermal and the hyperspectral one, are now at the same time happening, right? Just the next Transporter 12 mission in January, there will be 2 thermal companies from Germany launching, which I'm pretty happy about, Constellano, Vortec. But our question is always, like when Sven and I discussed the ecosystem, so there are multiple hyperspectral companies. Now, how do you differentiate to the others? Is there any special sauce you say you can do better than the others? I was impressed by your capital efficiency. That's definitely one thing. But maybe you can walk us like through your USP compared to the other companies like Wyvern, right? Pixel, which was also on the podcast. Super curious about that.
Absolutely. I think our main edge has always been cost and capability. I'll touch on capability first, because that's, something that's, again, as mentioned in my previous answer, it's being very much driven by customer demand and what our specific customer right now, the mineral exploration sector and the oil and gas sector, specifically what they need. That's what's really driving us, our specifications there, and driving us deeper into shortwave infrared. A lot of hyperspectral companies right now, everyone's going after different things. Somebody's really going after higher GSDs, and one wants to do all of it. What we're really focusing on is we really want to get high quality spectral data in shortwave infrared, because that's been a really big gap that we've seen in the market. And that's something a lot of our competitors are starting to realize as well. Now you see shortwave and SWIR, showing up in everybody's technology roadmaps over the next couple of years. But this is something that we've been really thinking deeply about and building technology around for the last couple of years at Esper. But just having that technology capability is not enough, especially if you're selling to customer, again, where as we sort of go through this conversation, we realize I'm so obsessed with the specific problems that we're solving for our exploration and oil and gas customers, that because they're the ones who are capturing really large swaths and really large area, that the economics of the data really impact their business case. Let's say if you're a mining company and you want to look at the entirety of Australia and be able to find a new lithium mine, that's about 7 million square kilometers. Right now, if you're looking at shortwave infrared data, even if it's multispectral and you're buying it from a commercial vendor, you're probably going to be paying 30 plus 45, 30 to like 45 USD per square kilometer. That is a really large amount, not even including the processing and the analytics that you need to do on top of that imagery data. That's where a lot of our cost piece really comes into play in terms of how we're actually reducing that data cost. Our target right now is to get to $1.50 per square kilometer for the entire data cube of data that we're offering, from visual to shortwave infrared. The way we've been basically able to do that is very much into the sensor itself and us developing that. And we've just been able to get really high quality imagery out of a much lower cost sensor. And all the way to how we develop the missions, how we process the data, what's on board our sensors in terms of processing, how much data we can get down, and what we're paying, let's say, per byte of that data to be downlinked. It's all been extremely engineered from a cost perspective in mind. So as much as we engineer our sensors, I feel like we're equally engineering our economics. And we really take after Umbra, where they, gave from Umbra, he talks a lot about unit economics. And that's something that's really, transferred over to us, where we're equally as obsessed. Like, I probably look at spreadsheets equally as my CTO looks at the technical designs that our team develops. So we're just so obsessed with just the unit economics of our business from a capital efficiency point of view, because we know this can drive down the cost, which further enables our customers to be able to operate their business cases.
Yeah, shout out to Joe Morrison. As always posting so entertaining LinkedIn posts, and really also very inspiring also for us. One question I would have though, and maybe that's a little bit of a critical question, isn't if the cost is the main driver, that potentially also race to the bottom, right? Because maybe I'll leave it with that. Would you say that you are at sometimes being squeezed by competition and by other players which are following the same route, and it's just like a no winners game?
That is a very good question. And I've probably fielded that question like so many times in the past. For us as a company, while we're getting to those really low numbers from a cost perspective, the magic of our economics is that we're still making like 80, 90% margin on top of that imagery data. So even if it's, let's say, a race to the bottom, we're still making so much more in terms of operational capital for us that it's, very less of an impact. However, though, because of that reduction in price, it's actually enabling a number of customers who previously could not have entered, let's say, these exploration companies. For them, it would have been too cost prohibitive for them to actually, let's say, capture the entirety of Australia. They're now able to do that. And this is, they're not the only company out there. There's, thousands of exploration firms looking at the entire globe, especially because of the macro trend that's going from a critical minerals point of view, in terms of just finding, better ore, finding the most easily extractable ore, all the way to, finding specific minerals of interest, right? While also being environmentally sustainable, because from governments now, there's a huge push on, sure, you're, mining all these areas, but there is so much more, environmental delicacy. It's a very delicate environment that a lot of these minerals are in. So us reducing this cost, while sure it may in a sense shrink the market, where suddenly we're like the lowest price provider and suddenly everyone else is having to sort of compete with us. But we think the number of entrants that are actually increasing in the market is just so much more. It's not the data is not becoming a commodity that way either, because just the amount of use and the amount of customers is just growing much faster than what the cost reduction curve would be.
Yeah, growing the TAM, and then because you have relatively fixed cost, right, you would increase the profit of the company in tandem. So you've mentioned also that you're doing a lot of things, and then you mentioned that you are doing these things very cost effectively. We've been on LinkedIn earlier today, and I think you have less than 20 employees listed on LinkedIn. And obviously that raises the question, like, how much are you doing in-house? What are you doing in-house? What are you outsourcing, right? One thing you've outsourced was to build the satellite bus in the past, right? Maybe you could shine some light on that.
So the two things that we really realized that matter in terms of data to our customer is the sensor payload, because that directly controls the specifications of your data. Assuming that you're going to be going on a standardized satellite bus, you have all the power and whatnot available from like a polar SSO orbit, And B is the data processing. Everything from data processing on board, the firmware that actually controls the sensor, which then eventually controls the actual specifications, to how do you, once you get the raw imagery down, how do you rectify it? How do you take it through the different levels and then eventually get to, the holy grail of analytics ready data? So those two things are primarily what we've been focusing on. And that's basically where a lot, like the Esper team is basically split. We have an entire data team, which completely focuses on everything from onboard firmware to building to, rectifying the data, building the processes in-house, take it to eventually to analytics ready data, all the way to, having image coordination with the satellite and tasking through the satellite to our hardware team, where they construct basically the entire payload from the ground up. Of course, we're not fabbing our own sensor chips per se or printing our own PCBs, but we're from a system level design point of view, it's a very low level that we take a sensor and then go up from there and have completely custom optics designed to our sensor. And so those things are primarily in-house. The reason why we've taken from a systems perspective, just picking those two things, obviously, as mentioned, from a customer point of view, our customer cares about the data. So we took the two variables that really impact the most on the data. And then from a satellite bus point of view, we realized that it's becoming much more of a solved problem where you have, providers on the hosted payload front, where you can just give your payload and then they can operate the satellite for you, all the way to, custom satellite builders where you can just, again, give your payload, then they build a entire spacecraft around it. So instead of us going out and hiring space systems engineers and finding this talent here in Australia, where, we're a very young space economy, just finding, our team has had to transfer the skill sets from like different areas into the company. It's been, that's in a way solved a lot of problems for us. It's just like, let's worry about it, let's just worry about what our customer cares about and what we can do to impact our customers' requirements, and then sort of outsource the rest of the logistics, in essence.
Yeah, and who wants to learn more about satellite as a service can listen to the podcast with Reflex or with Muon Space, which we did a couple of weeks or months back.
Exactly, it's a big trend. Yeah, is it public which company you used for the satellite bus?
Our first one went up with Space Machines Company. That mission was unfortunately lost, but now we have a second satellite that is now going up in January with Drua Space. So they built the entire spacecraft for us. We are working with a few other providers, but those are not public yet.
So you will go up with a Transporter 12 mission?
At the moment, we're slotted with ISRO, so I think that would be C59, I believe. But we have a backup on Transporter in case of delays or whatever.
Because it's also scheduled for January right now. But yeah, that's a topic for later. So what we see in the market of the satellite operators, they typically tend to build the data platform too late, right? So they focus 89% of the capital into the satellites, and then they realize, we have to distribute it and enable others to actually use it and buy it. And it seems like you already from day one invest into the data platform, right? So can you tell us a bit about the functionality of the platform, and is it already out there? Can people use it? And it's called Earthtone, right?
Yeah, that's right. Earthstones. I'm really proud of that name. So Earthstones is basically a data delivery platform. The approach that we've taken, and it is completely available. We have like all the APIs. It's not public yet. But if like somebody just like reaches out to us, we can definitely give you guys the API keys and then immediately plug into whatever system that you might have. And we're really, as mentioned previously, we're getting really closer to analytics ready data. We've been doing quite a lot of work on that, cross-functionally available around that. But so coming back to the point. So Earthstones is our data distribution system, primarily API focused. We do have a bit of a UI, but that's mostly just to play around with. But the way we've really thought about hyperspectral data specifically is that it's mostly going to be a machine that's going to be analyzing and going through our data rather than a human analyst, just because of the amount of data that's being generated and the type of data it is. And that's why we've just obscured everything that could be a point of friction from the user, just to make it, as easy as it can be for us to feed it into our customers' systems and whatever analysis that they might want to run on top of that. So our API is ready to go. We've already started delivering data with the last couple of weeks to some of our pilot customers through that API. And this was something that we've been investing from day one. And I remember writing some of the first code for the platform like ages ago, and my guys probably don't use that because it was pretty bad code back then. But now it's a very functional system, and a lot of our customers are already integrating that API-based system into their operational system, whether it be analytics firms or exploration firms where they have a lot of other data that they also want to reference, where like our team of data engineers are just like super obsessed with, again, here from a user functionality point, how can we make the ingestion of this data as easy as possible?
So it's really an API first approach, right? That's what I hear. The big question is, do you then also integrate into other providers like Skywatch or Up42, but you couldn't use their technology? So you had to build the starting point on your side, right? And then you can integrate and distribute. Yeah.
That's right. So the way we built our API is very, again, user-centric, where let's say, you're an analytics firm, you want, level 2A analytics ready data to be fed into your systems. We have that at point. But let's say you're a reseller and we've, whatever commercial agreement that we may have with a reseller restricts us to level 1B or one of these levels for the data. We have those different endpoints in the chain as well, because within Earthstones, not only is it an endpoint for data to be accessed by a lot of our customers, but it's also the same data pipeline that we operate a lot of our, corrections and just image processing on. So we just have so many different endpoints that we can directly connect into different customers' systems based on whatever their requirement is. So we have, I think these partnerships are public. So we have active partnerships with Skyfi and Skywatch at the moment from a reseller point of view. And recently we've started working with Wyvern as well. And Wyvern's interesting because a lot of people would have thought we're competitors, but we talked to the team and we actually realized we're a lot more complementary. So there's what we call a co-enrichment partnership, where we feel that just our data set alone itself is valuable to a customer. But if we pair it with Wyvern's, where they have, higher GSDs and their focus on their take on hyperspectral data is very complementary to ours, it overall becomes a very useful data set to the final customer.
Can you explain that quickly? Because like hyperspectral and hyperspectral, for the outsider, like maybe listeners who don't come from Earth observation, it sounds weird. Like it sounds like competitors, but why are you complementary?
So as previously mentioned, right, like we're medium resolution. We're not really going for really high GSDs. We're really optimizing for spectrum. That very much complements what Wyvern's been doing with their sensors, where they are fairly high GSDs. Their first couple of Dragonet satellites have been 5 meters GSD, and that operates very well with our high spectrum, high spectral resolution, whereas they have high GSD. So for a customer who's, let's say, you want to be able to take an outline of the plane, be able to classify it using Wyvern's hyperspectral, but then also want to do further spectral analysis. That's where our data then comes in and plugs into it. So from just an operational use case, it just makes each other's data sets a lot more valuable. So that's how we, again, as I mentioned at the start, everyone sort of has their own take on hyperspectral, and we've just found this, complementary field where we're like, what, if our customer uses both of our data sets together, it actually makes it it unlocks a lot more value for each of those data sets. And so it's been an interesting take that we've been taking, taken to this approach.
Yeah. So, I mean, right now there's no live sensor in orbit, but you have built hardware which is operational in orbit, but you've built hardware which has been launched into space, and there will be additional launches in the future. We've read online that in your early prototypes, you also used off-the-shelf components and cameras from classical camera companies like Canon. So what was the biggest challenge to get from there to having something which is space grade and can be used in orbit?
Yeah, I think I need to be careful here because I don't want to give away the secret sauce recipe, because that comes very close to it. So that's one of the reasons how we have been able to keep a lot of our costs down, is by being able to we've been able to basically build the process in-house. And it's not a single technology, but it's like multiple different technologies that we've had to design and engineer in-house to be able to take, a lot of these commercial level sensors that are not really built for space. And once you start opening up a DSLR camera, you can tell that it's not really built for that. It's obviously built for, regular user who may drop it on a hike somewhere, but not really something that can survive coronal mass ejections from the sun. So it's a lot of engineering effort that's gone into it. And I'd say, like, from our sensor design, that's it's a significant portion of it that goes into just our internal process of being able to do that. And that's, from a pure technology point of view, that's become a bit of a trade secret for us, where we can basically take any COTS sensor, and we've built this entire hardware stack and software stack that can basically integrate that into a high performance space rated hyperspectral sensor. So that, from a hardware point of view, that's been a core of our technology.
Okay, then we don't gonna drill deeper there.
So we had now a lot of exciting things, right? A lot of successes, and similar to our last podcast guest, Anthony Baker, the CEO of SatView, you also experienced a satellite failure, right? And we like the discussion with Anthony. Like it was very, very honest that, he said all eyes were on him regarding this. Every question was going to that direction. And can you share a bit the story about your failure and how you took it, and what did you already knew what's happening, and how do you overcome that?
Yeah, no, let's just say it's been a stressful year for us, huh? So to walk you guys through the story, so we built our first sensor, hyperspectral sensor called the Espresso, a very creatively named.
Good name. Yeah, you have to say you only have creative names with every product and everything you do.
Who's doing the names? Is it you? Is it you?
It is me. That's why I'm in the role I am.
Nice.
So when the company really started, we ended up winning a government grant from the Australian federal government to be able to build one of our first sensors and actually put it in orbit. So the half of the mission was funded by the Australian government, and as part of that, we collaborated with Space Machines Company, who are building OTVs, and they're an amazing team, and we were on one of their demonstration spacecraft. That launched on the Transporter 10 in March of 2024. Fortunately, due to a lot of variables that went into that launch, and we weren't the only ones impacted on that launch. The Space Machines missions operations team could just not get communication with that spacecraft. So while we had passed all the ground testing, we had done all the sensor level testing to be like, if this operates, we are good to go. We're going to get good data. We're going to calibrate. And then for us, mission success was getting to calibration. But yeah, we just could not get to that. While we were working on the Space Machines launch, we had built a second Espresso that was also meant to launch on a similar timeline, but with ISRO instead of the SpaceX. But due to, again, things out of our control, that launch has basically gotten delayed to this coming January at the moment. So that's basically, we were like, all right, first satellite gone, that's okay. If things go well, maybe in another month, we're going to be launching our second sensor. So it's going to be, another story of resilience where like, all right, first satellite went, whatever, second satellite's we basically put it up right after it. But again, the things as are in the space industry, when delays come, they just keep on coming. So it basically just pushed it out of the 2024 timeline. So what that left us with is just like, hey, we've done a launch, and we've told so many people that we've done a launch, and there's some publicity around it, but now we're getting asked all these questions of like, hey, does your sensor work? Did it operate? And we just can't say, because we ourselves didn't exactly know what's going on with the spacecraft, what's the problem. And eventually like a couple of months after that, we received news from Space Machines Company, or confirmation from Space Machines Company, that the satellite was lost. And that's when we released our statement. So it was a couple of tough times, and thankfully we had really great investors who supported us throughout the time, everything from helping us with technical support, helping find the spacecraft where it was, if eventually we could make contact with it, supporting us in other ways. So what we ended up doing to overcome, I guess, the mission, we called our entire demo mission campaign OTR, or Over the Rainbow. So we launched what we called OTR-X. So that is what we are currently operating. We basically bought timeshare on a very similar sensor, specification-wise, so that's already up in orbit. That was also launched on a similar time frame. So that basically allowed us to, now we're basically using that sensor and actively serving a lot of imagery to our customers. So just about a month ago, we published some, I guess, first light data. I say that in quotes because it's not necessarily first light of the sensor, but it's like first imagery that Esper's captured that we've delivered to our customer. And it's, again, very similar specs to our own sensor. So some of the contracts that we had signed are now being delivered on. So commercially, as a company, we just had to navigate us losing a satellite, our second one just getting delayed into oblivion, and then being like, right, with that, we just need to pray to the gods that there's another asset that we can just buy so we can start serving a lot of our customers. And that's eventually what we ended up doing. So now we have technically our third asset that we're currently operating. We're in the process of acquiring another fourth asset that not exactly our build, but another satellite, adding it to the OTRX mission campaign, just so we can keep on serving all the customers that we had promised that we would be delivering them data to. So we've thankfully, though, now a lot of our customers have been patient with us, and now we're delivering to them some really good imagery data, and it's proving out a lot of our business models that a lot of our investors are really happy to see as well.
But it's very impressive that you've been able to navigate that and that creatively as well, right? I would say that as likely some hesitancy with other satellite operators which say, well, our USP is our hardware, which, for example, then haven't built out really like the distribution model on the technical side with the platform and everything. I think like they wouldn't even be in a position to say, okay, well, we might buy data from other operators, resell it with our own systems, maybe don't have the same effects in terms of price or gross margins, but we can at least get business going. So that really kudos to you and team. That's very impressive. So what we've been reading is that, and it was on Payload, just to quote the source here, that you've been able to increase sales from 1 million to 10 million in data, which is also extremely impressive if you compare it to others. Have we read this right? Is this correct number?
Not exact numbers, but on the same order of magnitude, yes. Because of OTRX and the campaign that we launched behind it, and now that we have actual data, we had already basically garnered a lot of attention around just the business model and the cost and capability that we were offering, and that we basically built a real large pipeline, especially in the mining sector. So we've been, we have a couple of pilot customers. We're taking it a little bit slow. We've signed a couple of contracts and are signing more contracts that are coming into this mining book of business that we have. But now we're serving a couple of pilot customers, and then, going into 2025, we'll be scaling that out, especially once we have our OTR2 launch with ISRO come into the picture. So that will just increase a lot more data capacity available to us as well. So yeah, we've been like, again, the space industry has a weird way of humbling you. We were like, cocky 20-year-olds were like, you know what, we can do this. And it's like, first satellite lost, second delayed, they had to get a third. And then things just, it commercially, as I mentioned previously, right? Like we spent enough time, equal the amount of time engineering our economics as we do of our engineering our sensors. And it's just that, in a sense, I wouldn't say we're a product market fit yet, but we're getting really close to that. That's really allowing us to scale very quickly from a customer point of view.
And so just want to quickly mention what you said before. When you launched, there is a great company which can help you find your satellites. It's called Okapi Orbits from Germany. You need to talk to Christina. I can introduce you to them. They have a new launch and early orbit phase software exactly for these mass launches when a lot of small satellites go out. So if you are not connected to her, I will connect you to her. She was also on the podcast, of course. But the real thing which I wanted to ask you right now is, so you have just described this revenue jump, and I don't know of any successful satellite operator who is not doing significant or the majority of the business, not only government, but specifically defense contracts, right? So you didn't mention defense so far in the past. You talked about all the sustainability cases. And we see this big trend in the industry, right? So what is your perspective on that? Do you do also defense, or is this planned?
We've been exploring that market significantly. So I and my co-founder, we've been at a lot of the defense shows over the past 12 months, and we've already had some wins. Like about a year ago at Dubai Air Show, we had a pretty big win with the UAE Space Agency, and we're working pretty closely with them to get our data into their hands not from an exactly defense point of view, but from just like government use cases, from like civil and sustainability ones. A lot of our interest so far is still coming from commercial use cases. And that again goes back to us, from an economical model, from a pricing model, being able to actually really be catering to these customers, right? So, sure, we could be $100 per square kilometer. We can justify it being like, hey, we have the best sensor on the market from a spectral point of view, and just go for defense use cases, and we can still make a lot of that money. But we saw this untapped potential on the commercial side. And that's basically what's driving our business now, right? That's where our customers actually have been really adventurous with the data. So much that even after us, suffering a bit of a failure at the start of the year, they've been with us. They're buying imagery, and they're like actually basically putting money into the companies because they believe in the type of vision that we're trying to offer at the price point and at the economics that we're looking to offer them. So that's been a huge unlock for us. That being said, national security is something that we care about deeply as well. With the dynamics that are in the world right now, we do want to be, especially from an Australian angle, we do want to have a lot of sovereign capability to be able to have a lot of this ISR intelligence and being able to protect our allies and whatnot. And that's been something that we have been focusing on, and we have been working very closely with potential defense customers all across the globe, not just in Australia, across all of our allies that we have been, to see how can our data, especially at the scale that we can offer it, how can we, support large-scale ISR operations? No active sales and no active contracts as of yet, but that is an industry that we do, or that is a market that we do deeply care about.
And you've mentioned at the beginning that Australia has a relatively new space scene. We have customers in Australia. They come from the infrastructure sector. Maybe you could tell us a little bit more about how the Earth observation and space climate, space ecosystem is in Australia. Is there a lot of governmental support going on? And what's the general support towards Esper?
Yeah, great question. Space is new, but Earth observation itself is not exactly new in Australia. We have some of the best researchers, or some of the best, I guess, EO research in terms of analytics and just applications of EO coming out of the country. And that's actually been a bit of a driver, primarily, of course, being driven by industries like agriculture and like mining, which are huge contributors to the Australian GDP. And the more you optimize and the more you grow those with newer technology, that further pushes a lot of growth within research in the sector here. Space hardware development itself is, again, fairly new. I mean, don't quote me on this, but I think our space agency was founded in the last 6-7-ish years, right? So it's the space agency itself is fairly new. The regulations coming, or just the guardrails that we have, or just pathways that we have to get stuff into orbit, is also fairly new from a regulation point of view. So everyone's very much trying to figure it out. The government,
which is sometimes a great thing, right?
Yeah, I thought the same, Sven.
It definitely is.
The legacy,
I can probably talk a little bit more on that, but it definitely is a little bit for us where it being a bit of a wild west for us has actually, the government's actually been very much pushing for us to grow as quickly as we can. And that's been some of the largest support that we had, where Enrico Palermo is the head of the space agency, and we've spoken to him at length about this, and they're really open to just supporting not just the space agency, but the Department of Industry. I think that they're called Department of Industry and Science. There's some long name. They're supporting us quite a bit. There's the Department of Climate that's pushing for a lot of this EO data. So it's not just one space agency that's pushing for the company, but so many other industries that are pulling from a customer point of view all the data and the requirements that they have. While we're working with a lot of commercial players, we have a lot of civil customers in the pipeline as well from these sectors. Department of Climate, the Department of Resources, geological surveys that each and every state has. So we're doubling down on Australia in general at the moment.
Super exciting. Yeah, I just asked our AI overlord what's the biggest space company in Australia. It's not Esper yet, but I've seen there's Gilmore Space Technologies, just founded in 2013, right? So it shows, I mean, you mentioned 7 years, something like this, the space agency came, and a few years before that, this company, and it's already having 200 employees, and it's building launch vehicles, right? So also coming back to the sovereignty part, right? You mentioned. So there's a lot of dynamics globally, really exciting. And there's the Australian Space Agency's goal is to triple the nation's space sector revenue to 12 billion, create 20,000 new jobs by 2030. That's very ambitious goals. Really exciting. Yeah, also they are located in Queensland. I was there. Where are you located in Australia?
We're in Melbourne.
Melbourne. Okay, I think we have to visit you at some point in time in Australia.
Please do.
Yeah. So we are coming to an end of the podcast, and what we always like to ask is maybe I mean, you are the best example, prime example. Started the company with 21, you launched satellite, you lost the satellite, you launched the next one, and will be super successful. What is your advice to young entrepreneurs or people who want to start a company?
Get battle scars early. And I guess we've just gone through this, right? But as mentioned, right, like the space industry has a very good way of humbling you. And in a sense, that really, not to say that it puts you in your place per se, but that gives you the wisdom to actually really navigate and grow very quickly within the industry. It's like, honestly, like, I think it's still too soon for me to say like, oh, losing a satellite is the best thing that happened to us. I still wouldn't say that yet. But who knows, maybe a year down the line, we'll actually look back and just see what it sort of had. It forced us to evolve as a company and just focus on our business fundamentals, focus on our economics, focus on what the customer really cares about in the end. Like I come from a science background and I wanted to build really cool technology, but we've realized that engineering, again, I've probably this third time I'm saying this, but engineering the economics and engineering the market or market dynamics is as equally as important as engineering the actual hardware, engineering the sensor in our case.
100%.
So it's, getting those battle scars early for us has just been extremely, extremely valuable.
Nice. Well, I have to say that it was a very interesting and very inspiring conversation. I've learned a lot, and I really have to say it's always fascinating to listen to our podcast guests and to hear just the creative ideas, how they've built their own companies, right? We had this podcast, we talked about Umbra with Joe, very, very interesting views on how to build an Earth observation company. With the CEO of Skywatch, James, that was super interesting. With you, how you've approached it after your first satellite didn't go up. With the founder of Satellite View, how he's been able to build out the technical IP without building any hardware. So it's really, really interesting. And I think it's just fascinating. And I'm always getting out of these podcasts with an even bigger excitement about what the future will bring in Earth observation and the space sector at large. And maybe ending with that, before we really finish the podcast, we always ask our podcast guests, who should we have next on a podcast? So who should we bring on? What do you think?
It's very topical just because I was at the IMARC, which is the International Mining and Resources Conference just yesterday. We met with Flavia from Fleet. So Fleet has been doing great work in terms of, again, IoT and Earth observation from a mining perspective. And they're one of the hottest space companies in Australia, I'd say. And Flavia is great too. And just the entire team at Fleet has been doing extremely great work. So I definitely recommend them I definitely recommend you guys to bring them on.
And that would be super cool. I think we didn't have anyone yet from the IoT side, which is a shame because it is such an important line of business in the space sector. And we would love to get an intro from you. Thanks so much for being with us. It's late now; it's past 12, right, where you are at. So thank you very much for staying up.
12:15 a.m.
Yeah, thanks for staying up that late. Thanks for being here, and thanks for sharing all these interesting insights.
Thanks a lot for having me, guys.
Thank you.